this is going to be 1. How do I find the next term? What number now do I plug in for the next term? I just plugged in 0. And the ending value is 2. Doesn't mean I go right to 2. I plug in everything in between. So I still have to plug in what? Here we go. All right, what? I still have to plug in what? 1. So 3 minus 2a to the first. Anything to the first is itself. 3 minus 2a. And again, from yesterday, what's this sigma telling me to do as I go along here? Add up your terms. Yep. But you have one more to do, don't you? And that is to plug in what? All right. Unfortunately, now we got to do a little bit more work. Oh, you're seniors now. Hopefully, we're just not distributing that 2. Remember, this is the same as 3 minus 2a, 3 minus 2a. And then you're distributing it from there. So I'll ask somebody in a second what you end up getting. Combine all your like terms for me here. What are we looking at? Oh, there it goes. 1, not here. 11. 6 minus x and 6 minus x. Where'd that come from? Down the stairs to the sidewalk on Van Dyke. Okay, back to here because we're short on time now. 9 minus 12a plus 4a squared. Everyone all right? Combine your like terms, you end up with 4a squared minus 14a plus 13. All right, we okay on how I went from here to here? I double distributed, got negative 6a in the middle, and got negative 12a. That's where that came from. Okay. Are we all questions right now? We're good? Okay, let's move on here. And I apologize, I have to go a little quicker now. Which one of these sigmas represents this sequence up here? All right, so let's go one by one now. Starting value is 1. Go ahead, plug in 1. What do you get? What's the square root of 1? 1, which is my first term, but that doesn't cut it just because you get the first term. Now what would you have to plug in? I got 1, got it. Plus, what number do I plug in next? 2, okay, so I get the square root of 2, but still not good enough. You got to go through the entire sequence. Now what should I plug in? 3, but I get what? Square root of 3. I needed the cube root. Not going to happen. Does everyone see why that sequence doesn't represent that sigma? All right, we're good because I get the square root of 3 and I needed the cube root of 3. All right, so let's go to the next one. Well, let's start here first. What number am I going to start with? 0, and I'm going to end with 3. Ready? Do this with me. You're going to plug in 0, 1, 2, and then 3. How many terms are you going to get at the end? 4. How many are in mine? There's no way this one can work. I won't even bother plugging it in. Do you guys see that? All right, because there's 4 terms I'm going to end up getting, and I need 3. All right, let's keep going. Next one, I start by plugging in 1 for n. So what is 1 to the negative 1? Everyone's got calculators. 1 to the negative 1 does give me 1, so I'm okay so far. Ready? How about 2 to the negative 2 in your calculator? 2 to the negative 2. 1/4. But I needed square root of 2. Are those two the same values? 1/4 and the square root of 2. Nope. So that can't be it. So if we went and did the same thing for number 4, we know it's the right answer because we've eliminated everything. But if we went through and plugged in 1 and plugged in 2 and plugged in 3, we would have got those values. Okay, questions? Okay, quick review right now, and you don't have to write this down. Quick review here. 6, 10, 14, 18, 22. Why is that sequence arithmetic? Well, I'm adding 4 to each one, right? Adding 4. Everyone agree? Give me a name for that 4 that I'm adding. Yes, it's arithmetic because I'm adding 4 every time. What's that 4 called? It's got a vocabulary term. Common difference. And what's the letter for it? D. Where can I find the explicit formula for an arithmetic sequence? On your formula sheet. Are we okay with all this? Is there anything from the assignments that we want to go over now? Because I'll take that time right now before I get into the new stuff. Is there anything that you wanted me to go over either from the textbook or from your packet? Because this is a big chunk of Friday's test. Are we clear on what makes it arithmetic? Because I'm ready to go to a new sequence now. All right, take a look up here before I actually introduce it with notes. 3, 9, 27, 81. This is the new sequence we're going to be doing. How do you go from 3 to 9, 9 to 27? Multiply by a number. All right, multiply. So if I need to multiply by a number, I have a new sequence which is called geometric. All right, take a look. Geometric. That's when I multiply by a certain number. Now, you guys told me in the previous example that I was going by my arithmetic sequence. I was going by 4s, and that's called the common difference. Well, what you multiply by is not going to be called the common difference anymore. It's going to be called the common ratio. All right, and we denote that with a lowercase r. You guys had lowercase d for difference, lowercase r for the ratio. That's the number I'm multiplying by. All right, so take a look at my first example. Everyone see 32, 8, and 2. Just what's the pattern? That's all I want. What's the pattern? Sorry, I got to speak a little longer. I don't want anybody going a little nap time on me. What's the pattern? What about 4? Multiply that by 4? Everyone agrees, divide by 4. Okay, but when I talk a geometric sequence, I don't want to say divides by 4. Do you know what dividing by 4 is the same as multiplying by 1/4? Okay, so we're going to say this is going to be multiplying by 1/4. So what I need you guys to do right now, in your groups, find the next 3 terms. A4, A5, and A6. In your groups right now. Some of you are going to have to wait because it's tough to do without a calculator. One half, 1/8, 1/32. Yes? Dividing by 4, multiplying by 1/4. Okay. I'm not graphing this, not right now. Definitely don't have the time. What do you notice about, we'll just get rid of that. What do you notice about this sequence here? What did you guys say? You're dividing by what? Dividing by 4, which is the same as what? Multiplying by 1/4, 1/4. That 1/4 is called our common ratio with lowercase r. Common ratio. 1/4. Look on your formula sheet right now, please, if you have one. Do you see where it says geometric sequence? Do you see that? There's two formulas on there for geometric, correct? Geometric sequence and geometric series. We're looking at the geometric sequence one, because series from yesterday is when I do what? Series? When I add them all up, and we're not there yet. So you're looking at geometric sequence right now. Geometric sequence, that's the explicit formula we're going to use. Quick review. A subscript n, that's any term. Any term in that sequence. A sub 1 would be the first term. R is now called my common ratio. That's what I'm multiplying by. That n, remember what the n was in the arithmetic one. That's the position of the term you put here. Okay, so if you put the 12th term here, you put a 12 here. If you put the 10th term here, you put a 10 here. Okay, here we go. Find the 17th term now, the 17th term. This formula got right off the formula sheet. You guys have one right in front of you. Got it right off there. Find the 17th term. Okay, let's go. Who's got 6? Okay, here we go, Annika. Ready? 17th term, what's getting plugged in for n? 17. So ready? I'm going to find the 17th term by taking the first term, Annika, which is 1/16 times. Okay, now here's the tough part. What are you multiplying by here? 1, 4, 16. I'm multiplying by 4. So 4 raised to the, what did you just plug in for n? 17 minus 1. And we can all do that in our calculator right now. And you will get a very large number, and you're not incorrect. Yes, you do get a number in 268 million. Why do I get a number that large? Guys, what are you doing every time you go to the next term? Multiplying it by, you're going to get big really quick when you're multiplying by 4 and you're going out to 17 terms. All right, so that's why that number is so large, and it's correct. Questions? Okay, let me walk around and let me see you do number 2 right now. Okay, finding a sub n, but I give you the value of n is 6 already. Okay, so go ahead. This is geometric. Got the formula right in front of you. Plug away. Good, good. You guys are good. Good, good. Any issues with that one? Okay, ready to challenge yourself? I don't want to say much on this next one. Can you find the first term now? Using your explicit formula and the information I've given you here, can you guys find the first term? If you want to talk to people in your group, go ahead to hash it out. That's fine, all right? But remember, I have given you the 8th term, and I've given you the R value. Okay, so using this formula here, can you find out the first term? All right, instead of me just writing up what to do, find it, find it. Remember, you're going to have to plug in for everything except a sub 1. Leave that blank. All right, leave that as a subscript 1. and then plug that 20 in somewhere, get that 1/2 in there somewhere. The only place you may have trouble is solving it algebraically. It looks like a lot of you are plugging incorrectly. Just can you solve it algebraically now? No need for that one. That's the arithmetic one. No need for it. You wrote it down. You're looking for the first term, so I don't know why we're plugging in for the first term. We're looking for the first term. Okay, I'm seeing most of you guys set this up correctly. You're just having a little trouble solving algebraically, which I get. All right, here we go. This right here, any term in the sequence. I did give you any term. It's the 8th term, which is 20. That's any term in the sequence is 20. First term I'm trying to find. R value, 1/2. Here's where a lot of you guys did a real nice job. If I plugged in 20 here, what term is 20 in this sequence? It's the 8th term, so that's what I'm plugging up here. 8 minus 1. All right, let's keep going. Here's how you do it algebraically. 1/2 to the 7th. 20 equals a sub 1. What was that? 1 over, what was it? 128? Okay. All right, so how do I get rid of that? Well, what's happening between 1 over 128 and that a subscript 1? What operation? Multiplication. So how do you undo multiplication? Divide it. Or did anybody multiply both sides by 128? You could do that too. So divide both sides by 1 over 128. And your calculator can handle that now. So the first term ended up being, what do we have, 2,560? The first term. Before we go on, do you see why it's bigger than the 8th term? What's this R value tell? What's the 1/2 say? What's that telling me? To get to the next term, I multiply by 1/2, right? So how would I go backwards? Not multiply by 1/2, but multiply by 2. So do you see why this number is much bigger than the 8th term? Because if I go backwards, I'm going to have to keep multiplying by 2. All right? Okay, let's move then. Here you go. Write the equation for the nth term, which means get your explicit formula out and don't plug in for n. Leave n, n. Leave it as is. Okay, writing for the nth term. Okay, let's fill it in here. A subscript n is going to stay that way. Ethan, what's the first term? 5. The only work you guys really have to do for me is, what are they going by? Emily, what are they going by here? What's my multiplying by? 5, perfect. To the n minus 1, we don't plug in for n. Rookie mistake about to happen. You know what a lot of kids try to do, which is incorrect right now. They try to go that extra step and multiply the 5s. Nope, we're done. We are done right now. That's the nth. That's the equation for the nth term of that sequence. I do not multiply those 5s together. If I asked a part B and said, find the 100th term, what would you do from here? Find the 100th term. Plug in 100 for n if you wanted to find the 100th term using your equation. All right, a little bit different here. An. Okay, we know if I'm trying to find the equation for the nth term, what's the problem? I don't give you what? First term. Can you find the first term, though? Just like we did in problem number 3. All right, so I'll give you a second right now. Go ahead and find the first term. Just like we did in problem number 3 right now. Go ahead. Find a sub 1 so I can plug it into my formula now. Find the first term now. Leave it as a fraction if possible. Nice job, guys. Nice job finding the first term. Nice. 3, first term, R value of 8, raised to the 4 minus 1. Good. Three over 512. Plug that back in. Plug in your R value to the n minus 1. Again, don't pull the rookie mistake and try to multiply those two. It's as far as you can go. Seems like you guys are picking this up, which tells me arithmetic went pretty well then, if you're picking up the geometric this quickly. Any issues? Okay, let's go. We got a little quick word problem here. I start with 5,000 cubic centimeters of helium. Every day it loses a quarter of it, of 1/4. All right, loses a fourth of it every day. Write me the sequence, 5 terms. Write me 5 terms of how much helium is left. Not how much you lose, how much is left. So on day 1, I start with 5,000. It loses a quarter every day. What can I do now? Got my calculator in front of me. It's going to involve the number 5,000. What can I do now with that 5,000 to find out how much helium's left? Remember, it loses a quarter every day. You want me to divide it by 4? Multiply by a fourth? Yes, no? Okay, ready? But be careful here, ready? I'll divide by 4. I'm okay with that. Is that how much helium is left? That's how much I lose. Yes, everyone, we're all in agreement. So now what do I have to do with these two to find how much is left? Subtract it out. So 5,000 minus 1,250. Yep. So on the second day, actually, how much is left? 3,750. Does everybody see that this number represents how much I lose? Okay, so now figure out the third day. I have 3,750. You guys divide that. I'm going to keep doing what you told me. Divide it by 4, but that's not how much it's left. That's how much it loses there. So 3,750 minus the 937.5. And I think you guys can go on your own now to figure out at the 5th day how much is going to be left. Just make sure we're all in the same boat. How much helium's left? Okay. Any issues with how much is left? We're all in agreement, or did I make a mistake? We're all right? That's 03125 at the end, getting cut off there. All right, now write an equation right now. Write an equation. This is what type of sequence? Arithmetic or geometric? Geometric, all right. So if you want me to write the equation, I'm going to get out the explicit formula off my formula sheet and try to fill it in as much as possible except for n. Bless you. So I got A subscript n. First term was 5,000, no big deal. Here's where we got to be a little careful. What are we multiplying by? Because did we multiply by, we divided by 4, right? Which is multiplying by a fourth. When you multiply 5,000 by a fourth, do you get 3,750? No. So what really did I multiply here? Here's a trick. If you ever want to find the R value, here is a great trick. Brooke, pick any number in that sequence for me other than the first term. You can take any term in the sequence and divide it by the previous term. Matt, give me the previous term. Go ahead. That will always give you what you're multiplying by. If you take any term in the sequence and divide it by the previous one. So what did we end up multiplying all those by? 0.75 or 3/4? Does everyone see that little, I don't like to call it a trick because it's true all the time, but everyone see how you can find the R value if you're ever unsure of yourself. Take any term in the sequence and divide it by the previous. So 3/4 to the n minus 1. All right. Questions from you guys here? Okay. And I'm not going to do too much on these last two. You're going to do it all for me. Remember we had arithmetic means? What do I add? Remember, hey, this is what I'm talking about. And I don't remember the problem. I think it was a 2 instead, but remember this? Find out those three numbers arithmetically. All right, well, I can do the same thing geometrically. But now, what do I start with? 3 is the first term. 24 is the fourth term. Find the two numbers in between. Find the two numbers in between. Not yelling it out, but just thinking about it. What value do I need here? I got to multiply this number by 3. I got to multiply 3 by this number. Multiply it again, and I'll finally get 24. What is that value? What do we call that one today? It's geometric sequence. What did we call it? That's my R value, common ratio. We have a formula that contains the common ratio. Let's use it. Lucas, do you know any term in the sequence I can plug in here other than the first term? Okay, so 24 equals, Megan, what's the first term? 3. I'm trying to find out what that R value is. Ready, Isabella? I plugged 24 in here. What position is 24 in that sequence? It's the what term? The fourth term, so 4 minus 1. What's up, Matt? You all right? Okay. Oh, algebra, killing you. What do I do from here? Yeah, divide by 3. Yep, get that R by itself. R to the third equals 8. Now, do I want to take the square root? Nope, I want to take the cube root. Go to your math button on your calculator, and you will see the cube root button. It's been there. And the cube root of 8 is 2. What do I do with that 2 to finish this problem off? Remember, it's geometric. What do I do with the 2? Multiply by 2. Ready? So second term will be 6. Third term, 12. And then, hey, look, what happens when you multiply by 2 again? Must have did something right. I end up with that 24 I was given. So those are the 2 I need. Let me see you and your group do 7 on your own. I'm not going to show the work. I'll just write the final answer up here. Brooke, go ahead. Well, that's how much I'm taking out. And we're writing how much is left. So think about it. It's 100%. I take away a quarter of it. What's left over? That's 75%. Okay?